All right, let's go on to the second part of our notes. Look at number 3. It says reflect triangle PQR over the y-axis. So remember, if it's in the name, it stays the same. So this tells me for the y-axis that my y values will stay the same and my x values will become opposite. And we'll see that as we reflect across this line. So how far is r away from this line? Well, it's 2 away. So on the other side it has to be the same distance. So there's our r prime. Okay? How far is P away from the line? It is 7 away because it's at -7. So then this also has to be 7 away. Okay? And lastly for this one, Q is 5 away. So this also needs to be 5 away from our line, our Y line. This is Y, this is X. Okay? Practice labeling, it's very important. So now, if I see this, it looks like they're the same distance apart. And we know once again that our Y values stay the same. X values um, changed. They went from negative to positive, or they became opposite. Okay? So now, if I were to use the coordinate strategy, then let's use this one. Let's try that for reflecting across the x-axis. So we know that our new coordinates P, Q, and R are respectively P is 7, comma 2, Q is 5, comma 7, and R is 2, comma 2. Okay? So if we look at that, we're going to reflect across the x-axis, and remember, if it's in the name, it stays the same. So x stays the same, and y changes and becomes opposite. So on this case, we're going to use that strategy here because our rule is x stays the same and y becomes opposite. Okay? So what happens to my p double prime? This is my new shape that's going to reflect across the x-axis over here. This is q double prime and r double prime. So x stays the same, so it goes from 7 to 7, and my y becomes opposite. The opposite of positive 2 is negative 2, so that's negative 2. Okay, we do that again. So 5, it stays the same, so that's 5. And my y changes to become opposite, so that's negative 7. And last point for r is 2, so x stays the same, and our y becomes opposite, so that's negative 2. Now that I have my points, I should be able to graph these and see my new shape. So P is 7 comma negative 2, so we're going to go to 7 and go down 2. So that's P double prime. Okay, then we'll go to Q, which is 5 negative 7, so go 5 and go down 7. There's Q double prime. Okay, and then we'll go to R, and that's 2 negative 2, 2 negative 2. So there is R double prime. So notice we can see that we have reflected the P prime, Q prime, R prime, and now we have reflected across the x-axis, and we can see this reflection. So a note that we want to look at is that reflected figures have the letters of the vertices. They look like they're facing each other, so that's a good hint that this is a reflection. So across the y-axis, notice R is facing R, Q is facing Q. Across the x-axis, R is facing R, P is facing P. That's a good indicator that it's a reflection. Okay? So if we looked at number 5 says, Bella thinks that the transformation below represents a translation. Is she correct? Why or why not? Well, if this is a translation, remember, the vertices do not flip. The orientation does not change. It just simply slides with all the vertices staying in the same direction. Well, notice if this was a translation, H should still be in this location and I should still be in this location, but it looks like they have flipped. So because they have flipped, this is a reflection. The vertices have flipped. Okay, so what are some similarities and differences between translations and reflections? The big similarities, and you can write these down your own, so I can save a little bit of time here. Similarities, they do not change shape, they do not change size. Okay, they do not. The vertices do not rotate. Okay, um, the differences, though, however, is that the figure itself orients, which means think about like a selfie. So the figure might turn like if this is my hand, it goes like that, right? So that's the difference between translations and reflections. So now we're gonna go down here to number 7 and 8, and we're going to use what we know about reflections to fill in the pre-image and the new images on over the x-axis and y-axis. Okay, so now we know for reflection over x-axis, we know x stays the same, okay, and y changes, okay, and we know that y stays the same, and x changes. Okay, so if we look over here, we know that for reflection over x-axis, the y value is going to change. And reflection over the y-axis, the x value changes or becomes opposite. Okay, so what we're going to do now is we're going to look at our x value here. So y changes. So this tells me this should be 6 comma negative 8. Okay, for the next one, this should be negative 5 comma negative 1. And the next one should be 10 comma positive 9, because remember the x value is staying the same and the y value is changing. Okay, so then we have negative 4 comma positive 11, and then lastly we have 7 comma negative 12. So these are all of our new values reflected over the x-axis. Okay, so then let's look over the reflection over the y-axis. We're going to take our pre-image and reflect those over the y-axis. So we know that the x value changes, so that's going to be a negative 6. Y value stays the same, so 8. Okay, then we have a positive 5 because the x value changes, and a positive 1. Okay, and we're going to keep this going. We have a negative 10. We have a negative 9. Okay, we have a positive 4 and a negative 11. Okay, and then we have a negative 7 and a positive 12. Okay, let's close parentheses to finish it out. So to summarize, when we're talking reflection, we're talking about the same distance flipped over a line of reflection, and we can see that on a two-dimensional plane, and we're dealing with our lines of reflection of x and y. So remember, if it's in the name, it stays the same. Okay, so as we said, if it's a reflection over the x-axis, x stays the same and y changes or becomes opposite. And then if it's a reflection over the y-axis, y stays the same and the x changes and becomes opposite. Okay, we'll have some more practice to come. Thanks. Stay tuned for the next episode. Bye.